Hello everyone, in this part we have test hypothesis regarding two proportions from independent samples. So in this part we have two proportions. What that means, we're gonna have two populations. The first one here is this P1 is population proportion, N1 is size of sample for the first population, and X1 is number of successes in the sample for the first population. Now how we can find sample proportion for that population? Again, we had this part before, so point estimate or sample proportion is equal to x1 divided by n1, and finding q hat is based on what p hat is. Q hat is 1 minus p hat. Okay, so we have these two, and we call this q hat is complement of p hat. And that is same for the second population. So for second population, P2 is population proportion. Here is N2, X2, P hat, and Q hat. So this is for second population. Okay, then here on this part we have pooled sample proportion. So we need to find a point estimate of P because it is unknown. We don't have any information for the output. So the best point estimate of P is called the pooled estimate of P. Again, showing with P hat. The only difference here, this part is based on two populations set of 1. So before we had P hat equal to X divided by N, this was only for one population, but here since we have two populations, on top we have sum of X's and divided by denominator sum of N's. Okay, now testing it. Hypothesis test regarding the difference between two population proportions. First, we should have all these three requirements. So the same requirements. Again, we should have simple random sample. And N times P hat times Q hat should be equal to greater than equal to 10. But the only difference here in this part, since we have two populations, we have two steps. So N1 P hat 1, Q hat 1. This is for the first population, greater than equal to 10. Do same thing for second population. So we should have these two. And then the third one was that the sample values are independent. What that means, the sample size less than equal to 5% of population size. Okay, now following all these steps, here again we have 6 steps. So first one, determine null and alternative hypothesis. So first, finding what null alternative is. Here again we have two tail, left tail, and right tail. The only difference we have here on this part is that since we have two populations, we're gonna use the first population proportion equal to the second population proportion. Remember on previous sections we had, since we had one population, we had that one population proportion equal to some value on right side. Okay, but here we have the first population equal to second population proportion, and for all of these, for null we have equal to again. And here, since we have two tail for alternative, it's not equal to. And here, since this is left, we have less than. Here is right, we have greater. And I'll add something here that for H0 or H0, what this means, P1 equal to P2. This one means P1 minus P2 is equal to 0. Since these two are equal, if you subtract them, the difference is 0. So there is no difference. between proportions. Okay, then step 2, finding what alpha is. Alpha was level of significance. And that's depending on the seriousness of making a type 1 error. Then step 3, compute test statistic. What that means, finding Z. Okay, I want to compare this one with what we use for one population. So for one population, so recall Z was equal to P hat minus some value divided by P times Q divided by N. So divided by square root of P times Q divided by N. So this P0. With value of population proportion. Okay, now back to here. So again, Z is equal to now. The only difference, as I said, instead of using this P0, we're going to use the second sample proportion. So P hat 1 minus P hat 2, finding the difference between these two. And in some textbook, you can see that, okay, after this, you may see that we have minus P1 minus P2. I didn't write that part here because based on what I had on this part, we saw that P1 minus P2 was equal to 0. So we didn't write this part because this part was equal to 0. That's why instead of writing that, I wrote P hat 1 minus P hat 2. So that is enough. Okay, then divided by square root of P hat Q hat multiplied by square root of 1 over N1 plus 1 over N2. And here, again, how we can find this sample proportion or point estimate P hat was equal to on top sum of X divided by sum of N. Okay, then step 4, we should find p-value and then compare it with alpha. So p-value, again, same thing. When you have to tell p-value is the sum of the area and details, and here when it's left, p-value is area left of Z, and here when it's right, tell is p-value is area right of Z. Okay, then step 5, comparing p-value and alpha. If p-value was less than alpha, then that means that you should reject null hypothesis. Then step 6, state conclusion. Okay, now example. Yeah, this group conducted a poll in which they asked, are you in favor of or opposed to executing persons as a general policy when the crime was committed while under the age of 18? Of the 580 Catholics surveyed, 180 indicated they favored capital punishment. And here we have, of the 600 seculars surveyed, 238 favored capital punishment. Now the question is that, okay, is there a significant difference in the proportion of individuals in these groups in favor of capital punishment for persons under the age of 18. Alpha is given, so a second level of significance. Alpha is 1%. Okay, first I'm gonna write all these data for, okay, here we have Catholics, so I'm using C for Catholics. We have N is equal to 580. Out of that number, 180. Okay, that is X. Then we have, okay, for secures I'm using S. And here X. And S 600. And X is 238. Okay, then alpha is 1%. Okay, now we should find sample proportion for these two. For each one individually, so P hat C is equal to X C divided by N C. X is 180 divided by 580. Okay, that is 0.3103. Now for this group, X divided by N. X is 238 and N is 600. Okay, here we have 0.3967. Okay, then next step is should have all those three requirements. Okay, so I assume that we have simple random sample and all sample values are independent. So how we know that is, what that means we have the sample sizes less than or equal to 5% of population size. Okay, then next step. N times P hat times Q hat should be greater than or equal to 10. So we have two groups. We have NC times P hat C times Q hat C. That is equal to N is 580 times P hat was 0.3103. Q hat is 1 minus this number is 0.6897. So multiplying all these numbers, rounding it, it's 124, which is greater than or equal to 10. So that is correct. Now for second population, okay, N is 600. P hat 0.3967 times Q hat is 1 minus 0.3967 is 0.6033. Multiplying all these numbers, rounding it as 144. So it's greater than or equal to 10. Okay, after that, now testing it. So starting with step 1. So we have null and alternative, or null is the first population equal to the second population, and alternative, these two are not equal to. Why I have this part, why I have to tell? Because here the question was, is there a significant difference? So because of this one, is there a significant difference in the proportion of individuals? We don't see any greater than, less than, or something like that. We only see that there's significant difference. What that means, we should find out if there is any change or not. So what that means, should use the just total, which is not equal to. Okay, now step 2 was finding alpha. The output is given, alpha is 1%. Okay, then step 3, finding z. So to find z, we should find p hat first. So finding p hat is x plus x divided by n. Okay, so for x, c we have 180, 238, divided by 580 plus 600. Okay, the answer is 0.3542. Okay, then finding z. On top, finding the difference between sample proportions divided by square root of p hat times q hat. For this part, we're using what we got here, point estimate of population proportion, multiplied by 1 over n, square root of these two. Okay, so on top we have for p hat c and p hat s, 0.3103 minus 0.3967. Here p hat is 0.3542. Multiplied by q hat is 1 minus this number, 1 minus 0.3542, and it's 0.6458. Okay, then multiply by 1 over 580 plus 1 over 600. Okay, so the answer is negative 3.10. Okay, so that was Z. Okay, now step 4. Finding p-value. We have to tell so our z is negative 3.10. So that is on left, and here are, since I have to tell, so I have this part too. So this is positive 3.10. So p-value is sum of area of these two tells. So p-value is equal to, remember, I told you when you have two tell, you need to multiply by 2. So 2 multiplied by finding the p-value for one tell. So p-value for when z is, I'm working on left side because here I got negative 3.10, but there's no difference. So z less than negative 3.10, and that is equal to 2 times 0.001. So the answer is 0.002. Oh, I got that. Okay, to find this number, the p-value, I use calculator using normal CDF. We have this part before. So normal CDF. Since I'm working on left tail, starting from this side, we have negative infinite. Up to this point, we have negative 3.10. So lower bound is negative infinite, enter negative 1, then second, use division to enter that e, and then 99, comma. Now going to right, we have negative 3.10. Comma, mean is 0, standard deviation 1. Okay, then press enter. And the answer is 0.00096767. So we can round it to 0.001. And then after that, step 5, is that p-value less than alpha. So is this 0.002 less than alpha was 0.01. Okay, so the answer is yes. What that means, reject null hypothesis. So reject null. Okay, then step 6. State conclusion. What that means. Okay, so writing these in words, we have sufficient evidence to conclude that the proportion of Catholics that favor capital punishment is different from the proportion of seculars. So there is sufficient evidence. To conclude that the proportion of Catholics that favor capital punishment is different from the proportion of seculars. Okay, we finished that example. Okay, now next page. Okay, now in this part we want to construct a confidence interval for the difference between two population proportions. So we have these two population proportions, P1, P2. We want to find what that difference is. So if a confidence interval estimate of P1 minus P2 doesn't include 0, so if that was not equal to 0, we have evidence suggesting that P1 and P2 have different values. So remember on the first part I said that P1 minus P2, and that part we have that part equal to 0. But here, if we didn't have 0 on that part, we suggest that P1 and P2 have different values. Okay, so the confidence interval estimate of the difference P1, the difference between these two population proportions is, remember when we had one population here, I only had one P hat, so I had P hat minus plus E margin of error. But here we have two sample proportions. And so this E was equal to this critical value. Here again we have critical value. Now multiply by square root of this part again is based on two population proportions. Okay, so now example. Here again we have survey, and they ask how many tattoos do you currently have on your body. Of the 1,205 males surveyed, so 1,205, 181 responded that they had at least one tattoo, and of the 1,097 females surveyed, 143 responded that they had at least one tattoo. Construct a 95% confidence interval to judge whether the proportions of males that have at least one tattoo differ significantly from the proportion of females that have at least one tattoo. Okay, so let's first write all these data, what we have. So these are given. So for N, for males, I'm using M. So here on the upper we have 1,205. And for X, we have 181. For females, using F, so that is 1,097. And here is 143. Now finding point estimate sample proportion. Here for this group for males, sample proportion equal to X divided by N. X 181 divided by running it, the answer is 0.1502. Now P hat for females, X divided by N. X 143. Okay, rounding is 0.1304. Okay, then see on this part, alpha is not given. We only have this 95% confidence. So based on that, finding alpha, so 1 minus 95%. This is alpha. So alpha is equal to 5%. Then finding, since we gonna use this critical value, so finding Z. So Z alpha divided by 2. %5 divided by 2. So that is 0.025. Remember to find that part. This one is right area. So using calculator, inverse norm. And left we have 0.975. 0, 1. Okay, then interior rounding it, the answer is 1.96. Okay, we had this part before, that's why I'm not showing it on calculator. So, same thing. Just remember that since this is the right area, and when using a calculator, you need to enter, instead of that number, you need to enter 1 minus 0.025, which is 0.975, and this is left area. Okay, after that, finding our interval. So confidence interval. Okay, we should use these. So P1 hat minus P2 hat minus plus margin of error. So first finding E. So I need to find this part. P hat for males. So for Z, we got 1.96. Multiplied by P hat for males, we got 0.1502. Multiplied by Q hat is 1 minus this number, 1 minus 0.1502 is 0.8498 divided by N. So this was for males, and here females. P hat times Q hat, it's 1 minus this number is 0.8696 divided by N as 1097. Okay, you only get is 0.02835. Now we can find upper. Okay, so that is equal to this P hat is 0.1502 minus P hat for females is 0.1304 minus plus E margin of error is 0.02835. Okay, finding the difference between these two is 0.0198. Then adding, subtracting, margin of error. Okay, so based on these, now for lower one, what I have here is 0.0198 minus 0.0. That is negative . Okay, and then upper, adding these two. So that is equal to 0.0482. Okay, so confidence interval is okay, I want to run this one to 3 decimal places. So we have negative 0.009 comma, and here we have 0.048. Okay, so this is our final answer. Okay, now based on what the interval is, I want to see what is the conclusion. if we are rejecting null or not. So first, let me explain what null and alternative was for this part. It didn't ask us to find it, but I'm just writing it. So we had null was for males equal to females, and H1 is not equal to. Because here again, we don't see any greater than or less than. We only want to compare these two groups. So what that means, that P, these two population proportions, since are equal to, the difference is 0. So we have that 0. And I want to see if, do I have that 0 here in this interval? If I had that 0 in this interval, what that means, I'm not able to reject this null hypothesis. So since I have this 0 in this interval, what that means, these two population proportions are equal to. So since these two are equal to and the difference is equal to 0, and that 0 is in this interval, we're not able to reject null hypothesis. Okay, I'm writing that in words. Okay, since the interval contains zero, what that 0 was is the difference between these two. This 0. Okay. So since that since we have that 0 here in this interval, we don't reject. Null. Okay, what that means, that there is no difference in the proportion of males and females that have tattoos. Okay, we finished this part.